Okay, this is, I guess, day number 2. We're on this page 3, number 14. Graphing a hyperbola. Hyperbola is either going to look like this or going to look like this. So we have to tell what direction the hyperbola is. So the direction for a hyperbola, you don't look at the numbers in the bottom. That's for an ellipse. You look at what's positive, what comes first in standard form. So y comes first. Y is first. So this is vertical hyperbola. On the center of the hyperbola, you have to be really careful with this. The center of the hyperbola, you're going to do the opposite of -1. And the number with x is essentially a 0. But when you write it, the y coordinate is second. So the center is actually 0, 1. So you have to switch these. Switch these down here. So you have 0, 1s right here. Then we do the box. We do the box so we can draw asymptotes, diagonal dashed lines. So with the box, we look at the numbers in the bottom, and we take square roots of those. So the square root of 36 will give you plus or minus 6. And since it's under the y, that's up and down, 6. So 2, 4, 6. 1, 2, 3, 4. Right there. And then the square root of 4 is plus or minus 2, which is left and right. So left 2, right 2. And this gives us the box. You could essentially just draw the corners of the box is what you need. So those are the corners, and then you have your asymptote. Like that. The asymptotes also tell you how narrow or wide the hyperbola is. Make sure you hit this point on the box, and this point on the box is your vertices. You have a graph like that. That's your hyperbola. And that's the end of chapter 8. So chapter 7, chapter 8 are all done. Hopefully we'll do chapter 9 and chapter 10 today. Rational functions, these should go pretty fast. Rational functions, you factor, you get x plus 4, x minus 3, x plus 4, x plus 3. You divide common factors out, and you get x minus 3 over x plus 3. The next one, properties of exponents. Quantity raised to the 4th would be 16 x to the 8th. The 4 and the 2, be careful not to add those. You actually multiply those. You have x plus 1 times. You multiply by the reciprocal, so you have 9x squared. And then you can take a greatest common factor of 2 out. And you divide a bunch of stuff out. X plus 1, x plus 1. X to the 8, x squared is x to the 6th. So you would get 32x to the 6th over 9. Give you the answer. Thank you.
No problem.
The next two, more of the same. We factor first. We have r plus 4 times r minus 2. R plus 1, r plus 3. And division is going to become multiplication. So you can take a greatest common factor of 3 out. And then you divide common factors. You have some r minus 2s. You have an r plus 1. You have 3, r plus 4, divided by r plus 3. '17 is called a complex fraction. This fraction bar you're going to rewrite as a product. M cubed over 3n times the reciprocal of the denominator. And then you can divide a bunch of common things out. That's an m. That's an n. 9 and 3. That's a -3. So -3n over m. Add or subtract takes a little bit longer than multiplying. Adding or subtracting, you want lowest common denominator, LCD. So lowest common denominator here, you could multiply by 6x, but the lowest common denominator would be a 12 between 4 and 6. So you multiply by 3x in the top and bottom, multiply by 2y squared, 2y squared. So your answer would be 9x squared minus 2y cubed over 12xy squared. On the next one, you should factor first. M plus 2, M minus 2, plus 2, 3m plus 2. And then again, you need the lowest common denominator. So you need to see what one denominator has that the other needs. So this has a 3, this needs a 3 on that side. And then it's m minus 2, m minus 2. And then you could write the answer as the lowest common denominator. And the numerator would be 3m plus 2m minus 2 times 2 squared. And see if you could factor the next one and get the answer. On the next, number 19, graph without a graphing calculator. Identify vertical asymptotes, points of discontinuity, and graph. This sign chart is a typo. It should say table. Use a table of values. So with a point of discontinuity and a vertical asymptote, just to remind you, if you have a case like this where the factors divide out, that gives you a point of discontinuity when the denominator would equal 0. And -2, the denominator would equal 0. So that's point of discontinuity. So the graph looks like, has a hole in the graph like that. For a vertical asymptote, that's when you can't divide it out. Nothing simplifies. The x plus 2 is stuck in the denominator. So x minus 2 is a vertical asymptote, and that's a dashed line. So on questions like these, notice the x minus 2 stuck, nothing simplifies or divides out. So that lets us know that since nothing divides out, there's no points of discontinuity. And the vertical asymptote would be when the denominator equals 0, which is at x equals 2. Then when you make your table, put 2 in your table, and you pick a number to the left and to the right of 2. 2 is undefined when you plug it in. When you plug 1 in, you would get -3 over 1. And when you plug 3 in, you would get -3. So when you graph, it would look like this. 2 is undefined. 3, 1, -3. That is right here. And then 3, -3 is right here. And then you need to remember what the graphs look like. The graphs are captured by the x-axis and the asymptote. So you follow the x-axis and follow the asymptote, and it's kind of curved. So it looks like this on one side, and then the other side looks like that. So it looks like a funnel. The next graph we can factor, so we have x plus 6 over x minus 6x plus 6. Notice on this one you can divide something out. The x plus 6's divide out. So you're left with 1 over x minus 6. So since the x plus 6's divide out, x equals -6 is a point of discontinuity, and x equals 6 is a vertical asymptote. So on your table, you only put vertical asymptote values. You have 5, 6, 7. When you plug 5 in, you would get -1. When you plug 7 in, you get +1. And 6 is undefined. So your graph would be 5, 6, 7. I'll say -6 right there. Remember to graph the point of discontinuity. This scale is not very good. We'll just say that those are the actual numbers, just so I can fit it on there. So we have at negative 6, we have a point of discontinuity. Where's the point? -1. Also 1. So like that, and then this side looks like that. And I'll give you a chance. See if you can do the next one. I'm going to have to erase some stuff to fit it on there.
You are ready.
So let's skip the next one. Okay, on these, sketch a graph of each function. So here are some axes. I'll do those in black, and then we'll graph them in blue. Okay, so a constant function looks like what? Straight line, horizontal line. Direct variation looks like any vertical or any positive sloping line. And identity is really similar. The difference is identity has to be splitting it equally, 45 and 45 degree angle. Whereas direct variation, it doesn't matter if it slices quadrants 1 and 3 equally. Greatest integer looks like what?
Stairs.
Stairs. And absolute value looks like what?
Swing.
Looks like a V. Quadratic function looks like what?
U.
Looks like a U. Looks like me. Rational function, or the type that we were just drawing. That's an example of a rational function. Square root function looks like a parabola on its side. So those are some vocabulary terms that you should know. If I asked you those, you should know how to sketch those. Solve and check. On the first one, we can cross multiply. We have 5p equals 2p minus 2. We have 5p equals 2p minus 4. So 3p equals negative 4. P equals negative 4/3. Notice the directions. Say, watch out for extraneous solutions. Extraneous solutions are when your denominator would equal 0. You don't want p-values in this case, p. That would give a 0 in the denominator. So you would say p cannot equal 2. That would be extraneous. So in all of our work, if we got 2 as an answer, we'd have to cross it out and throw it out. That would be extraneous. We thought it was an answer, but it's not really. On the next one, what would be extraneous? One would be extraneous because if you plug 1 in, you would have 0 in the denominator. So when we solve this, if we get 1 as an answer, we have to throw it out. So we want all same denominators, so if you multiply by w minus 1 here, we would have w plus w times w minus 1 equals 4w minus 3. All of the denominators are the same, so we can ignore them. And we have w distribute here, 4w minus 3. We can get rid of w's and then subtract 4w and add 3 to set equal to 0. So when we factor, we have w equals 3, w equals 1. However, w equals 1 is extraneous, so only w equals 3 is the solution. W equals 1 is extraneous. And then on the last one in this row, we can cross multiply. We have x minus 2, x minus 6 equals x minus 2, or sorry, x minus 4. So x squared minus 8x plus 12 equals x squared minus 4x. We can subtract x squared from both sides and then solve for x. Add 8x. X is 3. In this case, you're watching out for 6 is extraneous, and 0 would be extraneous, but we got an answer of 3, so that's okay. exponent as a variable as an exponent, you would bring the exponent down by logging both sides. And then solving for p, you would have p equals log 10 over 3 log 4. And be careful when you do it on your calculator. If you do it all at once, you'd have log 10, which is really 1, divided by, you need a parenthesis right there if you're trying to type it in all at once. 3 log 4. So 5537. On the next one, I would give you this formula. It's on the first page of the final exam. So you have P is your principal, that's $300. R is your interest rate, which is 6%. N is monthly. T is what you're solving for. And A, you want your money to double. So that would be 600. You plug the numbers in, you have 600 equals 300. 1 plus 0.06 to the 12, divided by 12 to the 12t. And see if you could solve that for t. Solving exponential equations, logarithmic equations. You want to isolate e. Here's e. So isolate e, you would subtract 11 from both sides. You would divide by -3. And then from there, you would log, or ln specifically, ln both sides. So when you ln this side and ln this side, the ln and e cancel. So you have 4x equals ln 3. So x equals ln 3 over 4. When you type that in your calculator, it would look like this, ln 3, end parenthesis, divided by 4. 2747. On the next one, to get rid of an ln, you would e both sides. So the ln and e cancel, you have x plus 1 equals e to the first, x equals e minus 1, which is approximately 1.718. On the next question, I would give you these formulas. So a cup of coffee, 130 milligrams of caffeine. Caffeine eliminated at a rate of 11% per hour. How long will it take for half of the caffeine to be eliminated from the person's body? It's talking about eliminating, so you're going to use the 1 with a minus instead of a plus. So you need Y-A-R-T, yart. And the question is, how long will it take? How long will it take is a time question, so it's what you're solving for. The rate is 11%. The amount that you start with is 130, and you want half of the caffeine. Half of the caffeine is, half of 130 is 65. So you would have 65 equals 130, 1 minus 0.11 to the t, and see if you can solve that from there. Chapter 11.
What? You say chapter 10?
Chapter 11. So these formulas I'll give to you on the final exam, on the front page, final exam, all these formulas. So find the next 4 terms of the sequence. Next 4 terms, this is arithmetic. The difference between arithmetic and geometric. Arithmetic and geometric. Arithmetic, you're adding to get to the next term, adding some amount, constant. And geometric, you're multiplying by some number to get to the next term. So that's arithmetic versus geometric. Arithmetic sequence, you don't need a formula on these, just look at your pattern. You are adding 3 every time, so that's your D. So you'd have 1, 4, 7, 10. And let me get rid of that. That's better. On the next one, you're told d is -3, so that's just saying subtract 3 until you get the next 4 terms. Find the indicated term of the arithmetic sequence. So finding a term, you can use the formula. So the formula looks like this. And it's given to you, this arithmetic sequence formula. So a sub n is what you're solving for. That's a sub 12. A sub 1 is the first term. N is the number of terms. So if you're looking for a sub 12, 12 is the last term. The first to the 12th would be 12 terms. 12 minus 1. And d, if you're going from 8 to 3, you are subtracting 5. So d is -5. So you would have 8 plus -55, which is -47. Okay, on the next page, we have find the sum. Capital S is a sum. So the difference between a sequence and a series. Sequence is a bunch of numbers in some order. A series is you're adding the terms of a sequence. So you have to add 21 terms, starting at 76, and the last term is 176. This is arithmetic. So you can use this formula, the sum of 21 terms equals 21 over 2, 76 plus 176. And you can use your calculator and get the answer. Find the sum of the arithmetic series. Sum of the arithmetic series again. We'd like to use the same formula that we just used. It's the easiest formula to use for arithmetic sums, arithmetic series. But this one, we need an n. We don't know n. So we have to find out how many terms this is. So we could do 98 equals 7 plus n times your d. Your d would be adding 7 every time. Solving this, you would get 7n equals 98. So n is 14. And now you have n, you can do the sum of 14 terms is 14 over 2, the first term plus the last term, which is 7 times 105, 735. With sigma notation, you can tell that this is arithmetic because you have no power, no exponent. So you need the first term, the last term, and the number of terms. And then we can use the formula we've just used the past 2 times. So the first term you get by plugging the bottom number in, which would be 92. The next term you get by plugging the top number in, which would be 112. And the number of terms from 19 to 23. 19, 20, 21, 22, 23. 5 terms. So you have the sum of these 5 terms is 5 over 2, 92 plus 112.
That's all.
510. That's all. That's the answer for this.
I mean, that's all for today.
Thank you for your patience. That's success.
Okay, find the next 2 terms of the geometric sequence. You need to know what r is. You had 81 times r is 108. So r is 108 over 81. And I think that's 1.3 repeating. So when you multiply 144 times your r, which is 1.3 repeating, you get 192 as the next term. And then when you do 192 times 1.3 repeating, you would get, I think, 256. So those are the next 2 terms. The next 2 terms with this, multiplying by -1/2, you would multiply by -1/2. You can do that on your calculator. You don't really need a formula at all. -288 and positive 144. Find the indicated term for the geometric sequence. So geometric sequence formula, you would have a sub 8 equals 4096 1/4 is your r raised to the n minus 1, which is 8 minus 1. So you'd have 4096 times 1/4 to the 9th, which is 1/4. So that is the 8th term. Find the sum of the geometric series, the sum of 7 terms. This is a pretty long formula. You'd have 80, 1 minus -1/2 to the 7, divided by 1 minus -1/2. When you do that in your calculator, you should get 5375, but make sure that you use your calculator correctly on this, because with parentheses, students often miss one like that. So it'd look like this on your calculator. If you try to do it all at once at least, 80, parenthesis 1 minus -1/2 raised to the 7th, divided by 1.5 is 53.5. And we will stop there today. Check out the next video next time.